Azure Storage Queues is essentially a queuing service built on top of Azure Storage for storing large numbers of messages. You can access messages from anywhere in the world via authenticating calls using HTTP or HTTPS. A queue message can be up to 64 kilobytes in size. A queue may contain millions of messages up to the total capacity limit of a storage account. Queues are commonly used to create a backlog of work to process asynchronously. Queue storage contains the following components. All access to Azure Storage is done through a storage account. A queue contains a set of messages. The queue name must be all lowercase, and a message in any format of up to 64 kilobytes. The maximum time to live can be any positive number, or -1 indicating that the message doesn't expire. If this parameter is omitted, the default time to live is 7 days. So what are Azure Storage queues good for? Well, they are great in many different use cases. In general terms, we would talk about decoupling components. So the idea of taking two components instead of them communicating with each other directly to rather place a queue in between them, so that the service requesting some action or submitting some data can do so to a queue, so a middleman that can accept a message or a request without doing the processing. And then the service providing the actual capability or processing the data would take messages off that queue as fast as it can, but won't be overwhelmed with deluge of messages or requests, and it won't necessarily have to be available right at the moment where the client submits its request. So by decoupling components by placing a queue in between them, we get load smoothing. So you can send a lot of messages into the queue and have the queue grow in length without overwhelming the processor. And then similarly, we can add some resilience by decoupling components in this way by having momentary blips, unavailability of thin processing messages, being essentially invisible to the client submitting messages into the queue. From Microsoft's architecture guidance, there is actually a very good example that we use a lot. The idea is to take a web app as an example and consider how much traffic might be driven at that web app. Whether eBay, Amazon, or otherwise, you are going to have a lot of requests coming in for the service. So it could be retail checkout scenarios, could be video processing requirements, to generating thumbnails, but the web application itself has a lot of requests for work, and the client doesn't necessarily want to wait for that. So the client interacting with the web app wants to have a nice interactive experience. So the client submitting a request through the web app expects an immediate response, and the web app will place the request. Let's say a checkout request for a shopping cart into the queue and then tell the clients we are working on it. So the client has a nice interactive experience, but the work goes into the queue. And then we have a background task, in this case a web job, where we have the background task working as fast as possible, working through all the messages in the queue. So our focus is here where we are decoupling the web application from the background task. So if the web job becomes temporarily unavailable, even just for a moment, the web app won't be affected by it. The web app can continue to submit messages into the queue, and even if the web app starts sending a lot of messages, simply faster than the web job can consume, then we still have the ability to load smooth in that the queue will just grow in size. Once the web chore becomes available, or if it's just been very busy, when we add resources, it can then continue to process messages out of that queue at maximum rate. And so neither its availability nor its processing rate is directly going to affect the web application. This also means that we can scale these two components independently. And as we have more clients, we can scale our web application independently from the background task. We can also scale our background task perhaps based on high season, or as that queue length needs to be managed if it gets too large, or results don't appear quick enough for our clients. Then we can choose to invest in more web chore instances here and process the queue more quickly. So this is one example of how to use queues to decouple components. In this case, decoupling a web application from the background tasks could be generating thumbnails, encoding videos, checking out shopping carts, that sort of thing.